Let's look at some wind loads. So there's going to be sort of loads transferred laterally onto this sign. And we can put some numbers to this, so we can say, let's assume 1.2 kilonewtons worth of wind per meter squared. And if we put some dimensions on this sign, we can say maybe it's 1.5 meters high, and maybe 1 meter wide. So in total, that's going to give us 1.8 kilonewtons of force that we need to resist. And this force is going to be transferred onto the vertical members via these 4 little connections on the sides of the sign. It's going to be transferred equally, we assume, because it's got this axis of symmetry. So what we're going to get is we're going to get applied forces of 450 newtons on each of these, so 0.45 kilonewtons. And what this is going to do is put these 2 verticals below the first applied load into bending. And it's basically acting like a cantilever, because it's not really restrained at the top. These 2 members are basically acting independently. So as we move away, we get kind of a familiar triangular distribution down to this second one, where it's going to increase because we're going to have the effect of both of these 450 newton loads. So it's going to kink out again, and the bending moment diagram is going to look, let me just get rid of this 1.8 kilonewton thing. So the bending moment diagram is going to look like that all the way to, and it's going to be the same on the other side. We're going to get this shape of bending moment diagram, a sort of similar gradient until you get to the second point, and then it's going to be doubled. So most of the bending stress is going to be experienced at the bottom, which is kind of what we'd expect from a cantilever, but even more so because we've got this added force near the bottom. And now let's think about what's going to actually happen and on the horizontal, and how that's going to be transferred to this column. What you're going to do, what you're going to see, is you're going to see some torsional effects in this column, and they're going to actually transfer the load to the column as a concentrated moment. So finally, let's look at this column by itself. We've already got that concentrated moment, and we've got a horizontal load which is going to be transferred over from the top of the structure onto this bit. So if we try and draw the bending moment diagram here, that concentrated moment is going to give you an original jump in the bending moment diagram. It's going to be equivalent to the sum of the previous 2 moments on either side, and together we'll get that. And then because we've got this load, the gradient is going to continue all the way down to the bottom. So there, we've kind of almost got 2 different diagrams for 2 different parts of the structure. They come together as a whole.